Hi everyone, welcome to our presentation titled The Braille Challenge, Encouraging Excellence in Braille Reading. I'm Kay Holbrook, Professor of Special Education at the University of British Columbia.
I'm Robert Engelbretson in the Department of Linguistics at Rice University.
And I'm Simon Fischerbaum in the Department of Psychological Sciences at Rice University.
Thanks, Robert and Simon. I'm going to give you some background on this very special event, and then Robert and Simon are going to talk about some exciting research we have the opportunity to do to learn from Braille readers and their teachers. First, what is the Braille Challenge? The Braille Challenge is an academic competition for Braille reading students in the United States and Canada. It's designed to motivate and reward student excellence in reading. Blind or visually impaired students in grades 1 to 12, 6 to about 18 years old, are eligible to participate in the Braille Challenge at the preliminary stage. Based on performance, the top 50 students are invited to participate in a final round of competition, typically held as a two-day event in Los Angeles, but during 2020 and 2021, the final competition has been moved to a virtual event as a result of restrictions imposed by COVID-19. We have the opportunity to work with a lot of people who have been Braille participant enthusiasts for a lot of years. So we have some quotes here just to give you a sense of what people think about the Braille Challenge. One of our students who's at the foundational level, that would be below grade level reading, says, "I just love this Braille Challenge." And then a junior varsity level student said, "I enjoyed the Braille Challenge this year. Some of my favorite parts were competing against my friends, winning my new iPod Touch, and Papa John's pizza for lunch." Then we have some teachers who also are enthusiasts of the Braille Challenge, and Stacy, who is a teacher, said, "The Braille Challenge is so much more than just the competition. Students also have the opportunity to be with other kids who read Braille. And in the end, what counts the most is that you tried your best," said one of our sophomore level students. The Braille Challenge was started as an inspiration of people at the Braille Institute of America in Los Angeles, and it began as a small event, a regional event in Los Angeles and Southern California in 2000. It was quickly expanded to a regional contest in both Boston at the Carroll Center and additional expansion in Northern California in 2003. And then it became a national event held in 2001. The Braille Challenge grew into the current format with the first Braille Challenge Invitational event, including students from the United States and Canada in 2003. There are some specific goals for the Braille Challenge. It's a rigorous academic competition designed to motivate school-age Braille readers to excel in Braille. And the goals are to motivate school-age students with visual impairments to excel in reading and writing, to encourage efficiency and accuracy in reading and writing Braille, to provide a forum for students to participate in respectful and encouraging competition, to support families and provide them with an opportunity to celebrate Braille-related accomplishments, and to support high-quality instruction of Braille and Braille-related skills. The Braille Institute has chosen literary areas of focus that include both global literacy and literacy skills. The global literacy area of focus includes comprehension, reading continuous text in a variety of genres, poetry, charts and graphs, reading speed, and love of engagement in literacy activities. And then the skills that they address are spelling, scanning and searching, smooth, efficient Braille finger movements, speed and accuracy of writing, editing, and formatting. There's a high level of family involvement that is encouraged every year, and a high quality literacy instruction that is encouraged every year. There are 5 age groups that are included in the Braille Challenge. Apprentices about age 6 to 7, freshmen aged 8 to 9, 2 grade levels in both of those. Sophomore, ages 10 to 11, again, 2 grade levels. And then we expand it to junior varsity, which is 3 grade levels, ages about 12 to 14, and varsity about ages 15 to 18. And that takes you all the way from the beginning of school until the end of your school career. There are 2 stages of the Braille Challenge. The first stage is a preliminary contest, and everyone can compete in the preliminary contest. It's open to students in regional events or working individually with their teacher of students with visual impairments throughout Canada and the United States. The BC Braille Challenge is held on campus of the University of British Columbia, which is exciting for everyone. It gets students into the campus for an experience, and it also helps with people in the Faculty of Education who are involved in education. Students may participate at the preliminary contest in below grade level, which we're now calling foundational level, but those students are not eligible to attend the national contest. The final contest, or international contest, or invitational contest, is the top 50 students from the from the preliminary contests. It's usually held in Los Angeles, as I mentioned, at the Braille Institute, and recently we've moved on campus in Los Angeles at the University of Southern California. And it's held one day with excitement and games, very stiff competition, and a very exciting award ceremony at the end. Each level of contests, each grade level, participate in a slightly different types of contests. For example, spelling, proofreading, and reading comprehension are the contests that the youngest students, apprentice and freshman students, compete in. Then in the sophomore years, we add we add speed and accuracy to the sophomore level. And in junior varsity, proofreading, reading comprehension, speed and accuracy, and we add charts and graphs, which is also the same for the varsity.
Not only does the Braille Challenge encourage excellence in Braille reading and writing, and not only is it an exciting way for students to get practice with their Braille skills, to develop self-confidence, to celebrate the importance of Braille, and to have fun while doing it, but from another perspective, the Braille Challenge also enables rigorous and systematic research. Essentially because you've got a longitudinal research corpus of the same contests being done by students from across the United States and Canada. So every year, all of the students do the same things. They produce the same text, they are tested on the same spelling words in a given year. And that can then be tracked from year to year, and in that sense you have a longitudinal database of what students do in the Braille Challenge contests. And so now we're transitioning in our talk from talking about the Braille Challenge itself and the participants and how exciting a contest it is to what we as researchers can learn from the participants in the Braille Challenge by looking at the data. And this is one of the areas of a large grant that the three of us were awarded from the United States Department of Education. This is a 4-year grant from the Institute for Education Sciences, and we are researching Braille from 3 perspectives. The first perspective has to do with the skills, assumptions, and practices of teachers of students with visual impairments. And we're doing that through survey instruments, through having sighted teachers read Braille by sight and use eye tracking methodology to better understand how sighted people read Braille by eye, and to have some teachers do things like we find the students doing in the Braille Challenge contests themselves. So things like writing Braille to dictation, or maybe writing out some sentences to understand their facility in reading and writing Braille at some level, to compare that with the students. The second part of our research has to do with the skills of proficient adult Braille readers and how they read and write Braille. And again, we're using different methodologies and technology like finger tracking to track Braille readers as they read and to better understand the cognitive and perceptual underpinnings of the Braille reading process in an experienced population. We will also have adult proficient Braille readers do some of the writing tasks similar to what the students are doing in the Braille Challenge. And then the third part of our research is analyzing the spontaneous errors that children who participate in the Braille Challenge make as they're learning to read and write Braille. And it's this third area where the Braille Challenge contest allows us to directly address this question. The ultimate goals of our work have to do with promoting an evidence-based, cognitively realistic approach to teaching Braille. We want to make information available for teachers of students with visual impairments about the perceptual, cognitive, and linguistic processes that underlie Braille reading and writing. We want to ultimately be able to make recommendations for teacher preparation programs and for reading curricula about ways that Braille can best be taught and learned in a more cognitively realistic manner. And we want to explore student outcomes leading to greater Braille fluency and literacy. And the three of us would be happy to talk with any of you who have questions about our work. Feel free to contact us over email or talk with us in the question period. One of the things that's really exciting about our research team is that each of us brings some unique skills and experiences to this project. So Kay, of course, is a professor of special education and has great experience in how best to teach Braille and how best to prepare teachers of Braille. Simon is a cognitive scientist who has background and experience in reading and writing and neuroscience, and I am a linguist with background in language structure, and I also happen to be a lifelong Braille reader. The three of us have different lived experiences with Braille as well. So as I mentioned, I'm a lifelong Braille reader, Kay is an almost lifelong Braille teacher, and Simon is a little bit new to Braille as he's learning about it in part with this project. So it's exciting the perspectives that we're able to bring together to this work on Braille. This is truly a synergistic project in the sense that the work that the three of us are doing together is much greater than the work that any of the three of us could do on our own individually. This is team science at its best. So what do we know about reading and writing from a cognitive science perspective? Both psychology and linguistics and neuroscience and all the areas that go together to understand how the brain processes written language and how the brain learns to read and to write. And we're going to focus on English here in this next couple slides, although there's plenty of cross-linguistic work in the reading sciences that deal with all types of writing systems from a variety of languages. Although, frankly, there's not as much work on Braille as there should be, so we're aiming to change that. So the first thing that we need to point out is that kids know far more than what they are taught. I know I hate to break it to teachers, but we certainly teach kids things, but they end up learning far more than we ever teach them directly. The human brain is a pattern recognition machine, and kids learn to recognize far more patterns than they are ever taught directly. In that sense, learning to read is a kind of statistical learning. In other words, by exposure to a lot of reading, by doing a lot of reading, the brain develops pathways. The brain learns to automatically recognize statistical patterns in the words that it sees or feels. And that's one of the reasons why reading a lot is so very crucial for kids, well, for anyone throughout their lifetime as they read, actually. But the more you read, the more entrenched and automatic and fluent are the patterns that the brain is recognizing. Kids pick up on patterns in written words. Many of these really benefit from explicit teaching early on, such as, we know that it's very important to teach phonics. Phonics instruction is crucial for readers of English. And since we're talking about English, we have a fairly irregular system in terms of the orthography, so the spelling of words, matching to the phonology, the pronunciation of words. So some patterns in the matching of spelling to sound need to be explicitly taught, such as learning early on that the letter B represents the voiced bilabial stop phoneme B. But there are other patterns that are never explicitly taught, but through experimental work and observation, we know that kids know them anyway, even though they were never taught these things. For example, English reading kids implicitly end up knowing that C can be a double letter, but K cannot. And then finally, we're interested in invented spelling. In other words, as children are learning to read, the way they spell words often reflects the patterns they know about the mapping of letters to sounds and the structure of words. They invent spellings of words, although they're not the standard spellings of words that they would ever have come across when they're reading. But based on what they understand, the patterns of mapping orthography to phonology, in other words, the patterns of mapping letters to sounds, they'll come up with their own ideas of how words are spelled that they want to write. And those kinds of patterns are especially important in understanding the cognitive processes they're using when they're reading. So when we talk about analyzing student errors, we're not talking about student errors in order to correct them, but we're wanting to understand through the errors that students are making when they're writing dictation or writing spelling words in the Braille Challenge contest, what the student knows about reading as they're on their way to becoming fluent readers and writers.
Thanks, Robert. I am going to jump in here for just a minute because we know that that teachers play such an important role in teaching reading and writing through Braille to students that we do want to look a little bit more closely at what we know about teachers who teach Braille. So teachers typically learn Braille differently than children do. Most teachers of students with visual impairments are sighted, and they learn Braille as an overlay to their understanding and their ability to read and write print. Most students that they work with are learning Braille as a part of their learning to read and write. So teachers of students with visual impairments teach reading and writing through Braille for students who are beginners. This is influenced by how teachers of students with visual impairments are trained. And we have to explore that a little bit more to determine how teachers get past how they learned Braille and how they're teaching Braille, and the importance of teaching to the needs and perspectives of the particular student.
So now I'd like to move on and talk just briefly about English Braille. I know most of you know this, but since this is an international conference and many of you read Braille in multiple languages, I want to point out this out so that we're all on the same page, which is one of my favorite puns about reading. That English Braille is has both an uncontracted and a contracted form. In the United States, at least, in order to be a fully literate reader of English Braille, to read the magazines and books and publications that come from blindness organizations and Braille libraries and printing houses and such. It entails becoming a reader of contracted English Braille, or what we currently all now know as UEB, Unified English Braille. Unified English Braille has 180 contractions, so patterns that represent groups of letters. So for example, dots 1, 2, 4, 6 represent the letter sequence ED. So contractions make the statistical learning of Braille very different from the statistical learning for print readers. For example, teachers of the visually impaired, sighted teachers who learn Braille, learn it as a code. They learn that dots 1, 2, 4, 6 is decoded to the sequence of letters E followed by D. Now, students, on the other hand, kids who are learning Braille as their first and often only reading medium, are not mapping Braille onto print, of course. To become fluent readers of Braille, kids don't decode Braille contractions into full spelling and then recognize what the word is. Rather, in fluent reading, they recognize the word based on the statistical patterns they have picked up and encountered through reading Braille. So they know, for example, where the ED contraction occurs, what it co-occurs with, and maybe what parts of the word it's likely to be used in, those kinds of patterns.
All right, thank you so much, Robert. So I'm going to take over now, this is Simon, to talk a little bit about sort of how these differences in how teachers think about Braille and how kids think about Braille might be reflected in the kinds of errors that are getting made, and how we're then going to analyze the Braille challenge data to address these questions. And so to do this, I wanted to start with a really concrete example where you're imagining a TVI and a student who's learning Braille in an early literacy classroom. And so shown here is the kinds of phonics material that is really commonly used in a classroom setting. And so this is a sort of a phonics rule that gets taught, which is if you have the vowel team EE, it makes the sound long E, the E sound. And so shown here is the letters EE, print letters EE next to each other, and then a bunch of different pictures, a bee, teeth, feet, tree, and also a picture of a pack of seeds, all to illustrate how this vowel team EE goes together to make this sound long E. And so a teacher might say something like, notice the double E in seed. It's pronounced with a long E. So for the blind student learning how to read Braille, there is no double E in seed, meaning that there is no E cell followed by another E cell, because that second sort of E in the print spelling of seed is a part of the ED contraction. This might not be as much of a problem for the teacher who sort of learned this code-based approach to thinking about contractions, since that ED contraction means E followed by D. When you kind of unpack that contraction, this spelling still has two E's next to each other, just like you would have in the print spelling. And so you can imagine how learning how to read the word seed or spell the word seed might be challenging for the student who's being taught these rules that have to do with statistical patterns that exist in print English, but not necessarily in the Braille that they've been exposed to. So our broad research goals here are to ask, how is Braille read and written differently by the students and by their typically sighted teachers? And one approach to answering this question is to analyze the invented spellings produced by these kids in the Braille Challenge data, and to maybe pair these invented spellings with some things that we know about their teachers reporting about what they believe about Braille and what instructional strategies they use when they teach Braille, to see if some of this mismatch might have some impact on how Braille literacy is acquired. And so to do this, we now have a lot of data from the Braille Challenge, and we're actively in the process of taking that data and turning it into sort of hard-copied, brailled data, sheets and sheets of Braille that we're now turning into a digitized form of what people are producing in response to the tests in the Braille Challenge. And so we've completed the 2019 preliminary and final contests at all of the levels. And so we have over 1,000 different contests that we have been transcribing, rapidly transcribing, or as rapidly as we can. The individual contests are all de-identified, and we enter for individual students exactly what they're producing as a response to sort of each of the items in all of the contests. And so for the students that are doing a spelling test, that means that we have 40 words that are the target words that they're trying to spell, and we put down what they've brailled in response to those 40 target words. For the older students who are doing speed and accuracy, that means that they might have passages that have up to 800 words, or multiple passages, up to 800 words per student, and we put down sort of what they have brailled for each of those 800 words that they have attempted. And so we then have this opportunity to look at this data both by student to say, what are the kinds of what are the kinds of mistakes that this invented spellings that this student is making, and also by item. how are students doing across the board on these certain kinds of items that might be particularly challenging. So we now have the 2019 data. We're working currently on the 2020 data, which has been sent to British Columbia, where Kay has a group of people that are working on transcribing it. And the goal is to have many years of Braille challenge data available in a format that we can then analyze. And so here's just an example of kind of how we're planning on using this data. Here's an example from a 2019 spelling test. And so this is from the apprentice preliminary round. The students were asked to spell the word freedom. And I pull out this example because freedom has exactly that ED contraction where there are in print 2 E's that make that long E sound, that vowel team EE that makes the long E sound in print, but that's not actually how it's brailled once you introduce the contraction. And so the idea would be that if this is sort of a particularly hard pattern to learn for these kids, then the use of this contraction in this particular form should be really hard, should be particularly hard for the students. And so if we ignore the contraction, about a third of these 5- and 6-year-olds, first and second graders, are getting this word correct. And so they're spelling it either with the ED contraction or with the E cell and then the D cell. The remaining students, many of them are producing what you might expect from this age group, which are phonologically plausible spellings of this word. So say instead of the O at the end of freedom, they might be putting a U because that's a letter that could go with that sound. But if we look just at those 71 students that are getting sort of the right set of letters that you might think of in print, you can actually see that most of these students fail to appropriately use the contraction. Most of them, 55 out of the 71 of them, you write out 2 E's, the double E, like they might have been taught by their TBI to do that double E goes with the long E sound. Only 16 of the kids got the right spelling of the vowel and the contraction. So you might think maybe these kids just don't know how to use the contraction. Maybe they've only been exposed to uncontracted Braille at this point. But in fact, when we look at these kids spelling other words, we can see that they actually use the ED contraction correctly in other places when that ED contraction isn't violating this sort of boundary that seems really linguistically important, which is that, say that these 2 letters, E and E, go together to make this one sound, the long E. So in general, we find that when contractions break up important patterns, like the EE is a vowel team, it becomes really hard for these students to use them appropriately. So this is just obviously one example that is anecdotal in the way that we're really planning on doing this data analysis as a whole. So the goal is to do this kind of analysis, looking at how contractions are used, both in words where those contractions break up some pattern that seems to be really important for how you might think about the spelling of the word, and in cases where those contractions are not breaking up those kinds of patterns. And so by analyzing all of the written responses across all age groups and doing a much more complicated statistical analysis that controls for the various factors that a cognitive scientist of language like myself might want to control for, we're planning on investigating whether this phenomena that I showed you in freedom is actually a phenomena that shows up across all age groups. But we actually are able to do more than just that. And so we're able to look, if we get Braille challenge data from different years, so we're already doing 2019 and 2020, but the plan is to go back several years and to go forward several years so that we can actually get measurements of how the same student is doing at different years as they go up through their education. We can look at how this pattern changes as students learn. And then we also are planning on taking the kinds of information that we're going to get about teachers, the teachers' attitudes and knowledge about Braille that we're going to get from things like survey instruments, and linking them back to the Braille challenge data to see whether the kind of trajectory that students are taking over time is somehow related to ways that their teachers are approaching Braille. But even then, this is only sort of a limited approach to what we think can be done with this data. This is an unbelievably rich data set of children's Braille writing errors. And we think that it could be used to answer a wide variety of questions about the cognitive, perceptual, and linguistic underpinnings of how kids learn Braille. And so we, for example, are already looking at this set of data and looking at individual subjects and the kinds of words, individual kids, and the kinds of words that they're having trouble with to ask whether there are certain kids who, when you look at their patterns of what words they're having trouble spelling and the kinds of mistakes that they're making when they're spelling them, are showing what might be seen in the print literature as evidence of them having forms of developmental dyslexia or developmental dysgraphia, which has been really understudied in Braille. Is there evidence that some kids who are Braille users have these types of developmental differences that make print readers have dyslexia or dysgraphia? But these are, of course, only the questions that we can think about. So our plan in the end is to make this database that we're creating useful, that we're able to create because of the Braille Challenge and the amazing resources that the Braille Challenge has been able to provide to us. we want to make this database available to other researchers who can use it to ask other kinds of questions that they might have about how Braille is written. And so that ends our presentation about the Braille Challenge data. We're really excited to kind of launch into this project and be able to share all of this data that we're transcribing right now with you all so that you can answer whatever questions that you might have. And if you have any questions for us right now, we'll be available on email or in a question and answer period to be able to answer whatever you might want to know. Thank you very much.